It's finally time to fire my first ever wood kiln. I built it entirely myself, a mishmash of designs from various sources. Let's find out together how much I got right just by thinking and what needs tinkering. Eventually, I want to build a bigger kiln for cone 10 firings, but for now, I'm aiming for cone 6 in this little kiln. The journey to 1200 degrees Celsius begins with twigs. The fire starts on the floor of the kiln until I build up enough coals to move onto the grate. At that point, the heat of the coals ignites the wood above. For now, I'm feeding tiny twigs onto this finicky fire. This is not a how-to video, but hopefully it will be helpful if you're looking to build your own kiln. This is just a record of my very first time firing a wood kiln from start to finish all by myself. A kiln that I built by myself. You can see all of the elements of the build in previous videos. During this inaugural firing, I kept detailed notes, and I'll share all of the highlights and lowlights in this video. Hopefully this will help you focus your efforts if you're trying to build your own kiln. As soon as I switch to firing on the grate, I run into my first problem. And it's the one problem I swore to myself I would avoid having with the wood kiln. Look at this. Flames are licking back out of the firebox. Problem 1. The draft. This indicates a huge flaw. The whole idea of a wood kiln is that you have draft. Draft, also called the chimney effect or stack effect, is created by this temperature difference. The hot air rushes up out of the chimney, creating lower pressure inside the kiln chamber, and thus pulling in clean air through the firebox. If the flames are coming back out of the firebox, rather than rushing through the kiln and up the chimney, that means I don't have a strong enough draft. Watch what happens to this flame when I remove the brick that I placed to half cover the top of the chimney. It sucks right back in. This shows one variable affecting draft, the size of the chimney cross-section. Basically, the amount of air you can pull in is determined by how much air can escape at the top. A bigger chimney means more air escapes and more air is pulled in at the firebox to burn the wood.
Yeah, I'm sort of surprised that needs to be fully open. I guess like I should have a bigger flue hole there, because if it needs to be fully open now, that doesn't really bode well for when I'm burning more wood.
It's clear that this kiln isn't getting enough air. Even at these lower temperatures, I have the chimney fully open. So at higher temperatures, when I need to burn more wood to increase the temperature, you can bet there won't be enough air to do so. How did this happen? I followed plans that indicated this kiln would get sufficient air. Where did I deviate from those plans enough to mess up? Well, this is the big mystery. The obvious problem is the chimney itself. Maybe the size of the opening is big enough, but this lazy, short, gappy chimney isn't pulling enough. See, another factor affecting draft is the chimney height. Taller chimney means more draft. Another problem could be the lack of mortar in the kiln as a whole. All of these gaps between bricks throughout are air leaks. Draft depends on the pressure difference between the chimney top and the firebox below. If that pressure can be relieved elsewhere, then air is pulled in, for example, up here rather than down here where it burns the wood. So I have several ways to consider improving the draft in the kiln. In retrospect, I could have just stopped the firing here, made some adjustments to the design, and tried again tomorrow. But lacking experience, I just wasn't confident in my intuitive understanding of the situation, and I defaulted to delusional optimism. It turned out that my intuition was correct, but I wouldn't find that out for quite a while.
So I'm struggling to get consistent temperature rise in this little kiln, and there are a few obvious things that are wrong. The wood that I have is not dry. It takes a lot of heat to dry it out before it actually adds heat to the kiln. You can hear it hissing actually in the kiln right now. You can hear that water boiling off.
The solution is to burn drier wood. When I switched to very dry old pallet boards and even some dry oak firewood, the temperature rises much more reliably. Problem 3. the atmosphere.
This is not what I have in mind for this kiln. I do not want to be in heavy reduction.
This is directly related to the draft, but a separate concern. I can't control the atmosphere inside the kiln. See, what I want is to fire in a neutral atmosphere. That's where the wood is burning efficiently because it's getting enough oxygen, but not excess oxygen. Until I want to fire in a reduction atmosphere. This is with reduced oxygen. A reduction atmosphere gives a less efficient burn of the wood, but it's necessary for the effects I want in my clay and glazes. Oxidation and reduction actually refer to the chemical reactions that are happening here, but it's an easy mnemonic to remember that oxidation means there's excess oxygen in the atmosphere, and reduction means there's reduced oxygen in the atmosphere. The reduction that's taking place is actually changing one oxide form into another. For example, iron oxide is turned into a different form of iron oxide that has a different color, and it can even be reduced all the way down to iron metal. The same thing happens with copper. I often think of this as the fire is trying to find oxygen to help it burn. What's really happening is by starving the fuel, it could be wood or gas, you're producing something like carbon monoxide, and the carbon monoxide attaches to oxygen atoms more easily than iron. And so the carbon monoxide will steal oxygen from iron oxide, producing a different form of iron oxide and carbon dioxide. This is all a bit complex, but the outcomes are pretty obvious. A reduction-fired stoneware will turn out a deep red or orange, whereas in oxidation, the same clay might turn out a sort of grayish tan. There are two major downsides to firing constantly in heavy reduction. The first is, of course, it's less efficient, but also it risks making worse pots. You can get black coring where the iron oxide in the clay body is reduced inside of the clay, and it makes a very weak and brittle piece of pottery. All of this is to say, if I want to have any sort of control over my clay and glazes, I need to have some control over the atmosphere. Okay, so predictably, my first ever wood kiln has some shortcomings. But surely something went right, no? Absolutely. First, this lintel that I cast out of refractory cement held up wonderfully. Absolutely no indication of wear or stress at all. I feel confident using this product in other applications. The only thing left is to see how well it holds up with repeated firings. Similarly, the firebox grate that I welded up out of scrap rebar worked great. It didn't melt or warp, and the wood burned as well as it could have, given the lack of draft. If anything, the spacing of the grates might have been a little bit too far apart because my coal bed did build up a little higher than I expected. If I improve draft and burn more wood, that may be an issue, but by and large, this is a success. I'm especially happy considering how simple it was to build and the fact that it was just free, made of scrap rebar. I didn't have to buy any expensive stainless steel or anything like that. Success number 3, the roof. I worried a lot about the roof. This thing never sagged or moved at all. Nils Lou says you should periodically check and retighten the tie rods on this Minnesota flat top style roof, but after a single firing, it was rock solid. That was a huge relief. Success number 4, the bricks. These bricks held up great. Again, the real test will be how they hold up after 10, 20, 50 firings, but it is encouraging to see that they look perfect after the first firing. No cracks, no spalling, no melting, nothing. This was a short firing, but the bricks at the back of the kiln did get some ash, and honestly, they look no worse for wear.
I'm worn out. I'm out of wood. So that's it. My top temp right now, 1161, 1162. I just can't get it any hotter than that. Better luck next time, I guess. I don't know. I've been at this for 7 hours now, and I was hoping that this would take 3 to 4 hours. On a bigger wood kiln, 7 hours is nothing. That's just getting started. But for a tiny little kiln like this, I've only got 8 pots or something in it. 7 hours is a slog. So got to do some troubleshooting, try to figure this out. I know I want more air. Other than that, I don't know. 1170. Hey, that's a new high score.
By the following morning, the kiln is cooled off. So let's take a look at the results. I wasn't able to get the kiln up to temperature, so none of these pots are going to turn out. There's not really much of a reveal here, but that's okay. And predictably, all of the pots look absolutely terrible. So, inaugural wood firing, a complete failure in terms of the results of the pots because I wasn't able to get up to temperature, but a lot of really encouraging successes among the materials that I used. Going forward, I need to make some changes to the design. I already have a few things in mind, and hopefully those changes are improvements, and I'll continue learning how a wood kiln actually works and get closer and closer to my goal of having a larger Cone 10 wood kiln.
Thanks for watching.